Good morning, ladies and gentlemen. Welcome to our 13th lecture in the series of Philosophy of Science in Economics. If you recall, we have gone through a number of topics and issues which brought us to lecture 12, and which lecture 12 dealt with the rise and fall of pauper and lactose in economics. Now, if you recall, in that lecture, there are a number of things that we did cover, and the aspects that were considered then dealt with early engagements with pauper, lactose and emergence of economic methodology, the movement from pauper and lactose, and appraising economic theories and the methodology after lactose. Ladies and gentlemen, I'm sure you recall those specific aspects that we discussed and the various books that I gave you, asking you to go and read so that you try to understand the subject a little bit better. Today, in our lecture 13, we attempt to discuss a topic which is models and modeling in economics. Remember, we are dealing with the philosophy of science in economics. So models and the modeling in economics is supposed to be informed by philosophy of science. So the texts that I want you to look for and read, ladies and gentlemen, are, I want you to read Lawless and Constantineau, Dizboni, 2017. And this book is the Philosophical Hermeneutics and Hermeneutic Philosophy. The other book that I want you to read, ladies and gentlemen, is a book that's written by Heidegger, Martin, 1962, and that book deals with the major issues, if you really pick it, and those issues relate to modeling and models in economics, and those are the issues that we are going to discuss now. You can also look for a book that is written by Bulhof and published in 1980, slightly old, and it is on Dilthey's philosophy, Dilthey's philosophy of worldviews. That is another aspect that we are going to discuss today, ladies and gentlemen. I want you to also read the formation of the historical world in the human sciences, still by Dilthey. You can also read Rudolf Macmillan, and it is a philosopher of the human studies, Princeton. You can also read Aldrich, which is Halvenom's identification theory, that is an economic theory. Econometric theory, and you can also read Alexandrova, and this is connecting economic model to the real world. It's a game theory and the FCC spectrum auctions. That is a journal article, and I'm sure you'll find it quite useful. Now, in the interest of time, ladies and gentlemen, I may not be able to take you through all the books that you need, but these will be given to you on the screen. The structure of today's presentation, ladies and gentlemen, by the way, I should also prepare you a little bit early for you to expect this lecture to be slightly longer than the ones you've been attending. The previous lectures would take around 45 minutes or slightly less than that. This lecture will take a slightly longer time because the issues that I'm going to discuss require that time for us to understand what we are talking about. So, the issues we are going to discuss in today's lecture, ladies and gentlemen, include, I'll give you an introduction of what we mean by models and modeling in economics. I'll take you through the nature of economic models, and in this lecture of the nature of economic models, we shall look at idealization, we shall look at de-idealization, and the idealization versus de-idealization debate in econometrics. And for today's lecture, I'll be looking at only models of idealization. Now, in our subsequent lecture, we shall continue with the same discussion, and I'll take you to models as constructions. And when we reach there, ladies and gentlemen, you will appreciate that you can look at models in terms of ideal types and caricatures. So that is an aspect that we shall consider. We shall also look at fictions and artificial systems. And then we shall move to the other aspect of constructed representations. And we shall look at models as autonomous objects. So that will be another lecture that will follow after this one. And then we shall have another lecture, that will be the third lecture, where we shall discuss issues of working with the models in the area of economics. And here, issues of representation, issues of instruments and narratives, and looking at models and their epistemic functions will be quite important and relevant. And then, of course, at that material time, we shall look at the experimental exploration, conceptual exploration, and inferences from models. And then we shall have conclusions from models to modeling. So, ladies and gentlemen, as I said earlier on, please join me in this lecture as we start discussing the nature of economic models and going into models as idealization. So, in this lecture, I want to begin by letting you know that interest in modeling as a specific philosophical theme is both old and also new. So these are aspects that have been considered for a very long period of time, and it's an issue that has continued to surface in economics. And in the 19th century, the word model usually referred to concrete objects. And you need to understand that very well. In the 19th century, whenever you talk about the concept model, people would start thinking about concrete objects. And oftentimes, they were thinking about mechanical models that were built in an effort to grasp the functioning of unobserved theoretical entities. But I want to tell you that since then, the kinds of things which are referred to as models in science have multiplied. In fact, they can be physical three-dimensional things, as you're aware. They can also be diagrams. They can be mathematical equations, and they can also be computer programs or organisms and even laboratory populations. And this understanding at this material time, ladies and gentlemen, is quite important because quite often I meet individuals who discuss models, but in one way or the other do not even agree on what models are. And more specifically, when economists meet social scientists and they probably discussing models which are presented in diagrams, they tend to think that what those people are doing is very, very wrong and unacceptable. So when they come up with the conceptual systems in a conceptual model presented in diagrammatic form or fashion, they think that these fellows are doing a rather wrong thing, which is unacceptable in the area of economics. So I'm now telling you, ladies and gentlemen, that whereas in the 19th century they were looking at models in terms of physical objects that represented certain things, In the 20th century, the aspect of model has changed a little bit to include a number of things like the physical three-dimensional things that I've already mentioned. Diagrams are part of it, and mathematical equations are part of it. And that's why for you people who are in the area of social sciences again, maybe in the area of psychology, maybe in the area of marketing, area of accounting and finance, if you see an individual presenting a model in a form of mathematical equations, do not even at that much of time start asking him, where is your conceptual model? We cannot see it. A model can be a mathematical equation, or even a computer program, or organisms and even laboratory populations can constitute what we call a model. So ladies and gentlemen, this heterogeneity of models in science is matched in the widely different philosophical accounts of them. And these are the things that we intend to discuss. So discussions of models in the philosophy of science, ladies and gentlemen, testifies to a variety of theoretical, formal and practical aspirations that appear to have different and even conflicting aims. So you have to understand where an individual is coming from so that you understand the frame of mind and thinking and reasoning behind the models that are being presented. So we know very well that attempts have been made to establish within a formal framework what scientific models are, and I'm aware of that. So the discussion of models was originally motivated by practice-oriented considerations guided by an interest in scientific reasoning. So these aspects come from practice because people were practicing then wanted to see something that is real, that or something that would represent reality out there. So models come from practice, as you can see, and this is perhaps one reason why the general philosophy of science, as you can see, has tended to downplay models relative to theories. It's because of where the models are coming from. They are coming from practice, and therefore in the philosophy of science, models have been downplayed a little bit, as you can see in this case. And these models have been conceived by philosophy or philosophy of science as heuristic tools and interpretation of theories or means of prediction. And we stop at that. But I want to tell you, ladies and gentlemen, that recently, however, the situation has changed a little bit, as the models have come to occupy a never more central epistemological role in the present practice of many different sciences. So in an attempt to develop knowledge or a body of knowledge, then issues of models have come up to the fore, and therefore they are at the center of discussions that are taking place. So in almost every conversation, issues of models, issues of modeling will come up. And indeed, these models are very important. Models and modeling have become the predominant epistemic genre in economic science, and more so in the recent 20th century. So those are the issues that are being discussed now. Now, the term model, ladies and gentlemen, appeared in economics during the 1930s. Concepts like model and models were introduced then by the early econometricians, even though objects that were being considered as models were also being discussed and being produced then and discussed around that time. I'll give you an example. Marshall's 1890 supply-demand Caesar diagrams. I hope you have seen these diagrams, and I hope you know what these diagrams are. So Marshall's 1890 supply-demand Caesar diagrams represent models those particular objects, diagrams that you could look at. And that was slightly before the people started using rigorous mathematical modeling. So that's where we see that models have been central and at the center of economics for quite some time now. But I want to say that it was only after the 1950s that modeling became a widely recognized way of doing economic science. Whereas diagrams existed around 1890 with the supply-demand Caesar diagrams, it's only in the 50s that people started thinking about real serious mathematical modeling. And of course, it was recognized as a way of doing things in economic science. And during this time in the 50s, ladies and gentlemen, both statistical and empirical work in econometrics for theory building using mathematics and policy advice became very central and very important. And indeed, it became conventional then to link models to modern economics. And in this particular time, they were dealing with mathematical objects and also statistical objects. So statistics became an important tool to manipulate these models and equations that had been developed. So mathematical objects and the statistical objects came to the fore. And of course, when this happened, there was a division. So economics was divided into two aspects, as you can see. So the economic community divided into two, and one category of individuals were mainly practicing econometrics modeling, and that is statistically based modeling. And the other category of individuals or practitioners, they were in mathematical modeling. So as you can see, the economics community for the last half century has been divided into those two. Those mainly practicing econometrics modeling, and that is really statistically based. When we start talking about econometrics, it's statistically based modeling. And you also have those who are engaged in mathematical modeling. So those are aspects that are quite important for us to understand. So as we continue engaging or having discussions in these things. So ladies and gentlemen, this community division is reflected in the parallel bodies of commentary by philosophers of economics. So the philosophers have come up and they have attempted to analyze and discuss these things. So they have, for example, analyzed mathematical models in relation to economic theories. And they have also looked at econometric models in relation to statistical theories and statistical data. And that's why whenever these econometric models do surface, you see that a bigger portion of the discussions actually tends to take that element of statistics. So in other words, the econometric models are discussed in relation to statistical theories and statistical data. And of course, you also know that mathematical models have been again discussed in relation to economic theories. And that's why you have these two divisions of economists at that material time. So we can say, ladies and gentlemen, that these have usually been viewed as different sorts of models with different characteristics and differing roles, requiring different philosophical analysis. Now, this lecture, ladies and gentlemen, deals with both the so-called theoretical and empirical models of economics. And we do that without really assuming any principal difference between the two. and in contrast to the general philosophy of science, which has typically concentrated on mathematical modeling. So in this case, we cover various perspectives in this lecture, as I've already told you. And these various perspectives are centered on the philosophical status of economics, and also the different roles of models in economics. And we also attempt to discuss how these approaches fit into the modern science of economics, ladies and gentlemen. And then later on, as I take you to the next section, which is section 2, we shall spell out some main accounts on the kind of entities economic models are brought to be. And those are the ones I did tell you, although in order to categorize them in a general way, it is inevitable that the original accounts given by the different philosophers and economists presented are certainly more subtle and versatile than our classification suggests. So then we shall go to section 3, which will focus on how models are used in economics. And of course, we shall continue and continue and continue up to the time when we actually close, ladies and gentlemen. So, as I told you, allow me then to go through the first part of this lecture, which is actually the nature of economic models. And if you have any question, please jot those questions down, and we shall have an opportunity to discuss those aspects of the questions that you have. So, ladies and gentlemen, join me again as we go to this important aspect of the nature of economic models. Now, I want to let you know at this material time that modern economics does not differ from the other sciences, such as physics and biology. And in the previous lectures, I've told you that when you look at the way economics as a discipline has grown and how it has developed over time, it seems to really have borrowed a lot from the natural sciences or from the other physical sciences like physics and biology. So economics borrows a lot from physics and biology. Do not forget that. And this is so especially in its dependence on modeling. And what is quite interesting that although there is that perspective, economics again lies between natural sciences and the social sciences. In terms of the methods that are used and the variety of models that are utilized. And that's why I've talked about the mathematical models and the statistical models, which takes us into what we call econometrics. And those two are quite important because they have even brought up a division among economists to be classified as econometricians and those who prefer to use mathematics for modeling specific events and situations in the wider environment. So, ladies and gentlemen, core microeconomic theory has been axiomized, and economists use sophisticated mathematical methods in modeling economic phenomenon. So axioms are the order of the day. So macroeconomics relies in turn more on purpose-built models, often devised for policy advice. Do not forget that. And a range of empirical and statistical models operate across the board in economics. So it doesn't really matter where you are, but in case you take up econometrics, then you'll discover that a range of empirical and statistical models operate across the board in econometrics, ladies and gentlemen. Although the various model-based strategies of economics seem much like that of those of the natural sciences at the same time. So economists then share what we call a hermeneutic character with other social sciences. And I hope you know that when we talk about hermeneutics, you know the concepts that we are talking about. Hermeneutics is the art of understanding and of making oneself understood. So hermeneutics is a branch of philosophy. I hope you are aware of that. So But in this case, when you talk about hermeneutics, hermeneutics goes beyond mere logical analysis and general interpretive principles. And of course, the philosophers in the area of hermeneutics are really concerned with things like detailed and systematic examination of human understanding, and they're also preoccupied with the issues that are central to understanding or getting a common understanding across the board. And one of the early philosophers, ladies and gentlemen, behind hermeneutics is the German philosopher called Hans Georg Gadamer, who lived around, who lived in the 19th century. Ladies and gentlemen. So philosophers and the philosophical hermeneutics in this case pursues two broad questions that are fundamental to any efforts to transform a society. And those aspects are, one, it focuses on the culture of individuals within society, meaning that we need to really understand events and the interpretation of events from a cultural perspective, ladies and gentlemen. So a person tries to interpret the world around himself or herself, but this interpretation in turn affects the manner in which a person comes to think and also act. Now, one of the earliest philosophers that I've already given you are referred to as Dilthey. He has sought to resolve this question by putting forward a question of philosophy of worldviews. Unfortunately, this Dilthey's view has been dismissed by some scholars. So, for example, Heidegger, Martin, radicalized this concept that had been developed by the earlier scholars. And of course, he took it forward and tried to look at the roles and understanding and interpretation plays in our everyday life, ladies and gentlemen. So, in fact, Martin Heidegger asserts that understanding and interpretation are in fact constitutive of our very being as part of an existential structure known since antiquity. So since those olden days, we've been concerned with the issue of existence. So we need to understand our being in the wide environment and the interpretations we provide to the various events. So this Martin Heidegger then goes ahead and refers to this as hermeneutic circle, whereby we experience and try to understand and interpret anything new on the basis of what we already know. And that's why in our previous lectures, ladies and gentlemen, I invited you to read the works of personal construct theory by Kelly, 1957. And if you recall, I did tell you that Kelly looks at a human being as really a scientist, given the experience and, of course, the events that we go through in life and the kinds of things that we learn over time. So we tend to keep that information in our minds in terms of compartments. So wherever we are confronted with a situation or an event, we simply go into our minds and pick that kind of information and start letting that information to the other bits and parts of the information we have in the brain, and then test. And then whenever we accept that particular hypothesis that we have or conjecture that we have developed, then we go ahead and pattern our behavior accordingly, ladies and gentlemen. So the ideas of Martin Heidegger are not in any way significantly different from the ideas that are presented by personal construct psychology, and that is specifically Kelly in 1957, ladies and gentlemen. So the issues of hermeneutics become very central in modeling because you cannot understand models very well without really understanding what you are trying to model, and how you come up with equations, how you come up with symbols, and how you come up with diagrams to represent reality out there. And as you can see, although it sounds a little bit easy, that the job can easily be done, I want to tell you it's one of the most complicated and very difficult thing to do. So that's what it is, ladies and gentlemen. So do not forget, as we go through this lecture, that economics is in part based on everyday concepts such as economic agents ourselves. And we have a more or less good pre-understanding of various economic phenomenon. So whenever you start modeling, you are talking about individuals, and that's where we start. And that's why you have that division that you call the macroeconomics and microeconomics, right? So you need to understand the entire economy when you start dealing with the issues which are macro in nature, while you also have those issues which are micro when you start now thinking about the consumer the consumer within a particular economy. Therefore, individuals' knowledge of economics, ladies and gentlemen, feeds back into the economic behavior, and that of economic scientists feeds in turn into economic policy advice, giving economics a reflective character, quite unlike the natural sciences, ladies and gentlemen. So that's why economics is one of those more unique courses and disciplines. And the two major positions have been taken regarding the epistemic status of economic models. Ladies and gentlemen, the first position that has been taken is that economic models have been conceived of as idealized entities. Just try to remember what we covered in right from our lecture 6 up to lecture 10 and then lecture 12. The issues of idealization were discussed, right, as we are dealing with assumptions in modeling. And of course, those have been used as points of departure by the various social scientists to dismiss economics as a discipline that seems to produce and promote fiction, if you recall. So those were certain issues that were discussed in detail. But in the subsequent lectures, ladies and gentlemen, we are going to continue discussing issues of idealizations because they are at the center of economic modeling. So you cannot dismiss modeling in economics without discussing the issue of idealization. Idealization is quite important. So, ladies and gentlemen, from this perspective that we are discussing, economists are seen to make use of the stylized, simplifying, and even distorting assumptions as regards the real economics in their modeling activities. So in the style of modeling, economists, right, tend to use certainly simple what do you call simple and distorting assumptions. Right, so when you go into modeling activities, assumptions seem to be at the center of everything that we do in economics. And secondly, it has been suggested that models in economics are various kinds of purpose-built constructions. And don't forget that. So remember, these are kinds of purpose-built constructions. So some are considered to have a representational status, while others are considered as purely fictional or artificial entities. And therefore, ladies and gentlemen, when we start seeing models as constructions, then we need to understand the functional account of models. And this functional account of models can be seen in terms of having a model as an autonomous object or objects that mediate between the theory and data, and also a perspective which conveniently brings together mathematical and econometric models. So that's why models have been seen as constructions. Models in economics are seen as constructions because of the functional account of models. And this functional element brings in two aspects. One, the autonomous objects that mediate between the theory and data. And then number two, the models are seen as a perspective, right? A perspective which conveniently brings together mathematical and econometric models. And that's why we need to be very, very careful when we are discussing models in economics, so that we do not go overboard and tend to lean on the side of statistics, although econometrics is seen as really interpreting what is happening, but using statistical theories, ladies and gentlemen. So let's look at these constructions. It's very important for us to look at these models because we are dealing with the concept of modeling, ladies and gentlemen. So in this lecture, I will continue discussing these models, but we are going to look at models as idealizations. Remember, the concept of idealization has been at the core and is still at the core, and we shall continue discussing these aspects. So models can be seen as idealizations. And how do we see models as idealizations? In the general philosophy of science, ladies and gentlemen, models and idealizations are topics that tend to go together. You cannot separate models and also separate idealization on the other side of it. So philosophy of science will then bring together these models and then look at models and idealization. So models can also be idealized, as you can see. Now the term idealization here is generally used, ladies and gentlemen, but is a very difficult concept to define, as you will be seeing from my discussion here. And that's why during your free time, I want you to really go and dig deep into this concept of idealization so that you understand what people are referring to, because there will be, well, there are some shared meanings here and there, but there are also differences in the way people perceive this concept of idealization, ladies and gentlemen. So the introduction of the term idealization, ladies and gentlemen, owes its origin in the collection of essays in Bert Haminger and Neil D. Machi in 1994, in which then models are said variously to be the result of processes of generalizing, processes of simplifying, processes of abstracting, processes of isolating, following technical, substantive, and conceptual aims of requirements. So as you can see here, ladies and gentlemen, idealization is typically portrayed as a process that starts with the complicated world. So you start with the reality out there, and the world is considered to be complex. So the process of idealization, right, starts at a time when you are constructing reality out there. So that world that you see, and I hope you still remember our first lecture, which took us into reality, that reality is complex, reality is dynamic. So that's the complexity of the world out there. So the idealization process starts with that complication, right? So we start with a complicated world out there with the aim of simplifying it and isolating a small part of it for model representation. And this is not a simple task, ladies and gentlemen. Whereas some people simply rush, right, and they come up with symbols, they come up with models, and then they feed all this into some kind of statistical package, and they start manipulating statistics within a second. The fellow gives you a figure, and he says, well, this is what I'm getting as a beta coefficient, or maybe this is what I am getting as a correlation coefficient. And the fellow goes on and starts, the process, as you can see, is not very simple, right? But we go through idealization. Idealization is a process that starts with a complicated world with the aim of simplifying it and isolating a small part of it for model representation. As I told you, ladies and gentlemen, in this lecture I'm going to take slightly more time because we need to understand the process of modeling, because at the end of the day, this is what you are going to do when you are creating knowledge. So that's what it is. Now I want to refer you to a school that is referred to as the Poznan approach, right? And the Poznan school is actually the Poznan school in Poland that has gone through this idealization process, and they have their own understanding of what idealization is all about. So when we look at idealization in the Poznan approach, which is the Poznan school in Poland, they look at it in terms of complementing this idealization with a reverse process of concretization. So yes, it is true, we idealize, the world is very complicated. Our objective is to go through that process that will help us model it, but that is not sufficient from the Poznan approach. You must complement that idealization process with a reverse process of concretization. So that is quite important. So idealization, ladies and gentlemen, is the process by which scientific models assume facts about the phenomenon being modeled that are strictly false, but make models easier to understand or solve. So as you can see, so that's why, ladies and gentlemen, when you undertake research and you come up with results, you must give us limitations of your work. You cannot really assume that the model is really very superb, and then you start generalizing and say, well, my Gini coefficient is this, therefore this is what it is, without going through the limitations, right? Because first of all, the world that you are modeling is complex, but we try to simplify that world by using symbols or concepts, and then at the end of the day, use those particular things to test out a number of things, ladies and gentlemen. So those are very important aspects that we must really understand, because in this case, we must determine whether the phenomenon that we are trying to study approximates an ideal case. And then when that happens, the model is applied to make a prediction, and that prediction is based on an ideal case. So as you can see, the idealization process is really an approximation, right? And if an approximation is accurate, the model will have high predictive accuracy, ladies and gentlemen. I can give you an example. For example, it is not usually necessary to account for air resistance when determining the acceleration of a falling bowling ball, and doing so would be more complicated. So if you look at the modeling that is carried out in a particular body that is falling from up there and going down, and you are dealing with the acceleration and modeling acceleration, and then you start thinking about air resistance out there, that will make the entire process of modeling quite difficult. And that's why, actually, for a foreign object, we never look at air resistance in that particular aspect. And in this case, ladies and gentlemen, air resistance is idealized to be zero. Although this is not strictly true, it is a good approximation because its effects is negligible compared to that of gravity. So the pull by gravity is stronger than the air resistance that you are talking about there. So even in modeling, there are so many assumptions that we make, and the number of things are somehow ignored. So idealization, ladies and gentlemen, may not allow predictions to be made when none otherwise could be. So it's important for us to understand that. So, for example, the approximation of air resistance as zero, and that's the example I've just given you, was the only option before the formulation of Stokes' law allowed the calculation of drag forces. So when they were dealing with the Stokes' law to calculate the drag forces, then resistance of air, or air resistance, had to be approximated to zero. So the assumption was that air resistance does not exist in that particular aspect. So many debates, ladies and gentlemen, surrounding the usefulness of particular models or a particular model are about the appropriateness of different idealizations. So idealization will be there, but we need to discuss and understand them very well. I'll give you more examples since economics borrows a lot from natural sciences, from physics and biology. I'll take you to the works of Galileo, for example. Galileo utilized the concept of idealization in order to formulate the law of free fall. And Galileo, in his study of bodies in motion, set up experiments that assumed frictionless surfaces and spheres of perfect roundedness. And the crudity of ordinary objects has the potential to obscure their mathematical essence, as you can see. And idealization is used to combat these tendencies. So we partial out some of these things in the modeling process. So the most well-known example of idealization in Galileo's experiments is in his analysis of motion, ladies and gentlemen. So, as you will recall, Galileo predicted that if a perfectly round and smooth ball were rolled along a perfectly smooth horizontal plane, there would be nothing to stop the ball. In fact, it would slide instead of roll because rolling requires friction. So the issue of rolling was somehow dismissed in this. So this hypothesis, ladies and gentlemen, is predicated on the assumption that there is no air resistance. So very soon we shall be going into economics and then try to interrogate some of the things and the assumptions and the idealizations that are used in predicting or making predictions. So I'll also take you to another field, ladies and gentlemen, where idealizations are a form of the day. And let's go into geometry, for example. Geometry involves the process of idealization because it studies ideal entities, it studies ideal forms, and it studies ideal figures. And that's what geometry does. So they, for instance, assume perfect circles, perfect spheres, they assume straight lines and angles. Now, these perfect circles, ladies and gentlemen, and perfect spheres and straight lines and angles, ladies and gentlemen, are abstractions that help us think about and investigate the world. So we start thinking about the world and investigate the world when we start thinking about perfect circles. That, you know, you'll have a perfect circle somewhere, you'll have a perfect sphere, and you have straight lines, and then you have angles, and that is really geometry, and that's what geometry teaches us. So if this is done in geometry, then the same process of idealization can be done in other disciplines, and these are natural sciences, ladies and gentlemen. So if you take an example, physics, where we've just been a few minutes ago, people will often solve for Newtonian systems without friction. Friction is parceled out, and that is idealization, ladies and gentlemen. So while we know that friction is present in actual systems, ladies and gentlemen, solving the model without friction can provide insights to the behavior of actual systems where the force of friction is negligible, ladies and gentlemen. Let me now take you to economics, where we are now, because we are dealing with economics, ladies and gentlemen, right? And in economics, a notable proponent of idealization in both the natural sciences and the social sciences was the economist Milton Friedman, right? And in Milton Friedman's view, the standard by which we should assess any empirical theory is the accuracy of the predictions that a theory makes. And that's what Milton Friedman asserts. And Friedman, Milton, gives us an impression that the kind of things that we are dealing with amounts to what we call an instrumentalist conception of science, including social sciences, ladies and gentlemen. And of course, consistently with this conception, Milton Friedman argues against the criticism that we should reject an empirical theory if we find that the assumptions of that theory are not realistic. In fact, as economists came to the fore, some of them started critiquing and dismissing the assumptions that economists were using to argue out certain things and to construct knowledge in the area of economics. And Milton Friedman comes up and argues against those criticisms and critics, and he says we should reject an empirical theory if we find that the assumption of that theory are not realistic, should not be really taken up, because for him he thinks that yes, these ones could be an imperfect descriptions of reality out there, but they do tell us something about a perfect system that exists somewhere. So Milton Friedman claims that this criticism is wrong-headed because the assumptions of any empirical theory are necessarily unrealistic, since such a theory must abstract from a particular details of each instance of the phenomenon that the theory seeks to explain. So as I told you earlier on, reality is complex out there. So we must be able to go through the process of abstraction. We must be able to simplify that reality so that we come up with a model and test the model. Therefore, for you to reject a certain theory that has been developed on the basis of assumptions that you think are unrealistic is unacceptable to Milton Friedman, because Friedman believes that the assumptions of any empirical theory, ladies and gentlemen, are necessarily unrealistic. And it is true because such a theory must abstract from the particular details of each instance of the phenomenon that that theory seeks to explain. So this leads Milton Friedman to make certain conclusions. And Friedman actually says that truly important and significant hypotheses will be found to have assumptions that are wildly inaccurate, descriptive representations of reality in general, and most significant, the theory, the more significant the theory is, the more unrealistic the assumptions are. So in this light, ladies and gentlemen, Milton Friedman makes really an important argument, an important case that we cannot simply dismiss, because in most cases we try to understand reality and make sense of that reality. So in this light, ladies and gentlemen, Milton Friedman makes the case for seeing the assumptions of neoclassical positive economics as not importantly different from the idealizations that are employed in natural sciences. And of course, drawing a comparison between treating a falling body as if it were falling in a vacuum and ignoring the issues of friction. And of course, in the sense of economics, viewing firms as if they were rational actors seeking to maximize expected returns. And that's what we usually say in the neoclassical economics. So you assume you dismiss all the other things and assume that a firm will always seek to maximize returns, as if that's the only thing that firms can actually seek to maximize. So, ladies and gentlemen, against this instrumentalist conception, which judges empirical theories on the basis of their predictive success, the social scientist and the social theorist called John Elster has argued that an explanation in the social sciences is more convincing when it opens the black box. And according to John Elster, this black box that is referring to is when the explanation specifies a chain of events leading from the independent variable to the dependent variable. And in research, you know very well that the phenomenon that we are interested in, the phenomenon that we seek to explain, is represented by the dependent variable, or what we refer to as the criterion variable. But then it is these other independent variables that do provide an explanation or prediction of the criterion variable. So John Elster, that social theorist, argues that we need to open up this black box so that we understand what is there. And in his thinking, that opening up provides a set of explanation, right? And that explanation should specify a chain of events leading from the independent variable to the dependent variable, ladies and gentlemen. So John Elster continues to argue that the more detailed this chain is, the less likely the explanation specifying that chain is neglecting a hidden variable that could account for both the independent variable and the dependent variable. So we need to really juggle out and try to understand how these variables relate to one another so that we are able to parcel out those other things that may not be particularly important in any particular epistemic justification of a discipline. So, as you can see, John Elster also contends that social scientific explanations should be formulated in terms of causal mechanisms, which he defined as frequently occurring and easily recognizable causal patterns that are triggered under generally unknown conditions or with intermediate and indeterminate consequences, ladies and gentlemen. So John Elster is simply telling us things that we need to really think about in this perspective as we are conducting the modeling process so that we understand idealization very, very well. So that contention that explanations, and these are now scientific explanations, are formulated in terms of causal mechanism is very important. And in his case, the causal mechanisms are seen in terms of frequently occurring and easily recognizable causal patterns that are probably triggered by a number of conditions within our modeling process. Now, all this, ladies and gentlemen, informs John Elster's disagreement with the rational choice theory in general and Friedman's in particular. So Elster disagrees with the rational choice theory in general and also disagrees with Friedman in particular. And as you can see here, the Elster's analysis, I'm talking about John Elster, the Elster's analysis simply tells us that we need to think, don't simply take things for granted, right? But somehow Elster says that Friedman is right to argue that criticizing the assumption of any empirical theory is unrealistic and misguided, right? But Elster also says he is mistaken to defend on this basis the value of rational choice theory in social sciences, especially in economics. Elster, in this case, presents two reasons for why this is the case. He says, first, rational choice theory does not illuminate a mechanism that brings about non-intentionally, right, the same outcome that a super-rational agent could have calculated intentionally. I hope you get this. Right, that's his first reason. He presents that. Elster, right, presents his argument and defends his argument, right, by saying that, you know, Friedman was not really right and he was mistaken to defend the rational choice theory, right? And to Elster, he gives two reasons, right? One, he says, the rational choice theory does not illuminate a mechanism that brings about non-intentionally the same outcome that a super-rational agent could have calculated intentionally. So that's really the first point he raises. And in that case, he actually says that's a mechanism that would simulate rationality. So the issue of rationality is downplayed in that conception. So Elster also continues to argue and brings out a second point of contention. And he says that because explanations drawing on rational choice theory do not provide pinpoint predictions, which in certain courses, ladies and gentlemen, would be sufficient to convince one that the theory making these predictions is likely to be true. So according to him, you do not have those particular cases, right, like the ones we do have in quantum mechanics, that would be sufficient to convince one that the theory making these predictions is likely to be true. So in which case, the concept is actually dismissed. And accordingly, Elster wonders whether the as-if assumptions of rational choice theory help explain any social or political phenomenon. So I want to invite you to go and read, ladies and gentlemen, so that you understand those concepts very well. Remember, we are dealing with the ideas, ladies and gentlemen. We're actually discussing concepts that relate to models being seen as idealizations. We are in the modeling process, right? And you can look at models as idealizations. So since we are dealing with the issue of idealization, we continue to pursue our discussion of idealization. So the basic idea that philosophers of economics have derived from Mill, I hope you still remember John Stuart Mill, is to conceive of models as abstracting causally relevant capacities or factors of the real world. And that's where we started. Can we abstract? In other words, if the reality is out there and we see events, right, and we see the economic system, right, unfolding before us, before our presence, and we want to understand the events taking place there, can we then abstract causally relevant capacities or factors of the real world for the purpose of making out deductively what effects those few isolated capacities or factors have in a particular model? I think you can see that the modeling process is a complicated one, ladies and gentlemen. So for you who is going to do this and contribute to knowledge, you must know very well what you are going into. And that's why in the past, ladies and gentlemen attending this lecture, I've told you that the moment you complete your PhD, you'll be humbled, right? A PhD humbles because you will realize that you probably do not know anything, or you'll discover that even modeling process is very complex. Even attempting to develop a theory is not very easy because your theory can easily be dismissed and replaced with other theories that do come up with the probably better abstractions of reality and better conception of the events, the way they unfold, and the relationship between these events in that particular environment, ladies and gentlemen. So, against that background, then you have other scholars who have come up to contribute to the debate, and that is really Cartwright. Cartwright in 1989 and 1994. Of course, Cartwright has written a lot. And he has worked alongside Mackey, and I've already asked you to read the works of Mackey. And Cartwright's work, ladies and gentlemen, focuses on what you call the causal capacities that are supposed to work in the real world, and associating the aim of discovering them as being evident in and applicable to both mathematical and econometric modeling. So Cartwright attempts to defend mathematical modeling and econometric modeling as one of the basic features of abstracting and picking ideas and concepts and examining the capacities of these aspects that are supposed to work in the real world, ladies and gentlemen. And according to Cartwright, despite the messiness of the economic world, there are sometimes found invariant associations between events, and therefore these events must be studied. So you will see events wherever you are, and it really depends on the kind of lens that you use to examine those particular events, ladies and gentlemen. So Cartwright, 1999, argues that in these associations, causal capacities work together in particular configurations, which she calls nomological machines. For you have already studied the confirmatory factor analysis and of course, the exploratory factor analysis, but going into confirmatory factor analysis, you may have discovered the importance of nomological nets, which are important. So Cartwright argues that in trying to abstract the world and try to find the associations between events in this kind of environment, then the causal capacities work together in particular configurations, which she actually calls nomological machines, ladies and gentlemen. So mathematical models in economics are constructed as blueprints. You assume perfectly divisible products, perfectly divisible goods. You assume infinitely elastic demand curves, which are commonly made and taken by economists as, not as distortions. So as you can see, these assumptions here really, it's an attempt to abstract, but you can see that such situations, right, which call for idealizations in economics, may not really represent the truth out there, ladies and gentlemen. So that's why some scholars have called for the de-idealization. Remember, I've taken you through idealization, but you have the de-idealization, and then at a later stage, I'll be taking you through idealization versus de-idealization. So let's understand the de-idealization process, ladies and gentlemen. As we have seen from our previous discussion in the last few minutes, the term idealization covers different strategies and consequently ways of justifying them. And one influential defense of idealization is the idea of de-idealization, that you idealize and then de-idealize, right? So you abstract, right, but then at the end of the day, de-abstract. And that's not a very easy thing, as you can see. So one influential defense of idealization is the idea of de-idealization, according to which the advancement of science will correct the distortions affected by idealizations. And of course, add back the discarded elements. So that as you bring in elements in your modeling process, right, you have your dependent, independent, mediating, and moderating, whatever it is, and then you have gone through the ceteris paribus, right, the items that you can legitimately consider leaving out, and of course those ones that have minimal effect. Right, now during that process, right, it has been argued that during the process of modeling, right, you bring in all those aspects one at a time, etc., and then you start removing some of those elements again to see how these distortions are affected by idealization process. So you get them out, you add back the discarded elements, thus making the theoretical representations become more useful or usefully concrete or particular in this case. So a classic formulation of this position was provided by Tajlings-Koopmans, who thought of models only as intermediary versions of theories. And of course, in this case, he thinks that these models enable the economist to reason his or her way through the relations between complicated sets of postulates. And in the process of discussions, that's why Koopmans has been actually quoted discussing issues which relate to economic theory as a consequence of models. So Koopmans looks at economic theory as a consequence of models. And for him, he simply says that considerations of this order suggest that, of course, that would have already given you, right, of adding and subtracting and doing all sorts of things, right? But he says that this order suggests that we look upon economic theory as a sequence of conceptual models that seek to express in simplified form different aspects of an always more complicated reality. So that's why you bring in this, you remove that, and so forth, ladies and gentlemen. So I think, as you can see, that's why we go through the process of idealization and de-idealization, ladies and gentlemen. So That's why Newark also comes up and says that science should eventually remove the counter-actual idealization in a process of concretization. So it is also possible to see the move to greater realism as a process of reversing idealizations, ladies and gentlemen. So what I'll do at this stage is to try and move away from this, but I'll ask you to go and read and read and read and read and read in the interest of time, because we cannot really cover all these things in this lecture, so you have to go and read. So it's important for us to go through this process. And that's why some scholars actually believe that the method of modeling in economics should perhaps rather be compared with the use of models in sciences, such as meteorology, such as ecology, such as population biology, sciences, which do not so much lack comprehensive foundations as the relatively well-behaved systems. So you need to look at economics in that perspective. And there's a general belief that, you can also use models that are robust enough to bring out interpretations. So the kind of thing that you are doing allows idealization and de-idealization to be informative. So that's why you have idealization at one stage and de-idealization at the other stage. And an alternative defense and interpretation of highly idealized models has been claimed in what several analysts following Richard Levin's 1996 have called robustness analysis. So in modeling process, you must actually convince us that your model is robust. Now, this robustness, again, must be looked at critically. What robustness are you talking about? Is it robustness in terms of abstraction of reality and trying to de-idealize, and that is concretize what you are talking about? Or robustness is seen in terms of the robust statistical tools and estimations that you are coming up with, or the models that you are dealing with in econometrics, ladies and gentlemen. So, as you can see, robustness can be characterized as stability in a result that has been determined by various independent scientific activities. For instance, through observation, through experiments, and mathematical derivation. So we need to be robust in what we are doing. We need to develop robust models, right? So that's why we must now supplement the models and the kind of methodologies that we have, right? And that's why you bring in observations, you bring in experiments, and you bring in mathematical derivation, ladies and gentlemen. But applied just to modeling, right, where it has been taken to mean the search for predictions common to several independent models, the notion of robustness must, however, have a weaker epistemological power in that perspective. So if you only look at econometric modeling without now supplementing that with other aspects that I've called, for instance, observations, ladies and gentlemen, right? I've told you that experiments are also other things that you can add to spice up your analysis and study, and mathematical derivations. So the moment you bring in observation, experiment, etc., then you can talk about models that are robust enough, ladies and gentlemen. So allow me to close, ladies and gentlemen, by looking at our last aspect, and that is the third aspect that compares now idealization and de-idealization in econometrics. So I want to introduce this debate: idealization or de-idealization. So while the language of idealization and de-idealization is not so familiar, ladies and gentlemen, in the philosophy of econometric models, these processes are endemic in the practices of econometrics at both grand and everyday levels. Now, at a meta level, ladies and gentlemen, the argument about the process of modeling in econometrics is exactly one as to whether it should proceed by processes of idealizations or by ones of de-idealizations. So where do we start and where do we end? Where do we combine these two processes so that you idealize and then at the end of the day you de-idealize through the concretization process? So at a major everyday level, ladies and gentlemen, we find that practical modeling in econometrics involves many processes of idealization and de-idealization at the same time. Now, at the practical level, ladies and gentlemen, that is making and testing the validity of idealization decisions in econometrics, right? We go through a similar range of processes where we introduce questions, and these are economic questions, right, that are actually discussed, and the same questions that are introduced in econometrics are the same questions that are actually introduced in mathematical models. And those questions, ladies and gentlemen, those questions will center around which variables should be included in the model and which variables should be omitted from the model. What are the key causal relations between these variables? What simplifying assumptions can be made, ladies and gentlemen? What ceteris paribus clauses are involved in these modeling processes? What tractability assumptions need to be made, ladies and gentlemen? What is the nature of their statistical and mathematical form, ladies and gentlemen? And we continue asking questions after questions, a question after a question. Now, economic modeling, ladies and gentlemen, right, the way we know it today, right, includes making, testing, idealizing assumptions about the nature of economic data. It goes ahead to explore the probability distributions assumed, the nature of the errors, the stochastic behaviors found in particular kinds of data, and so on and so on. However, in a significant difference with mathematical modeling, right? So we see a variation between economic modeling and mathematical modeling. So econometric modeling, which uses statistical manipulations as opposed to mathematical modeling that uses purely mathematics. So, in a significant difference with the mathematical modeling, ladies and gentlemen, econometric modeling involves a whole lot of de-idealization decisions that are required to bring the requirements of the theory into some kind of coherence with available data. Let's just give you an example, right? For example, economic theory models, right, rarely specify very clearly the details of time relations or the particular form of entities or relationships involved, and all these details have to be filled in the model, ladies and gentlemen. So every modeling decision in econometrics involves a dilemma of how to measure the terms that economists use in their theories, and sometimes these measures are termed proxies, because the theoretical term wanted is not one that is measured, and other times it is a choice of what data best matched the conceptualized abstract terms of economist models. So the introduction of proxies in the models in econometrics also makes the modeling decisions very difficult and introduces a dilemma. So proxies are one part of the story. The second part is that modeling is carried out for many purposes in econometrics. One, to test theories. Two, to measure relations. Three, to explain events. Four, ladies and gentlemen, to predict outcomes. And five, to analyze policy choices, ladies and gentlemen. Now, each of these four things that I've just given you, each one of them will need different statistical and economic resources and invoking different criteria in the modeling processes. And that makes the whole process not a simple one, as you can see. But that doesn't mean that you can't model. No, you can still model. So all this activity, ladies and gentlemen, means that econometric modeling involves processes of both idealization and de-idealization, right? And the way this is done in economics is very much an applied science, because each model has to be crafted from particular materials for particular purposes, and such skills are learned through apprenticeship and experience as much as by book learning. Therefore, at the meta level, the argument over modeling, ladies and gentlemen, is concerned with the relative role of the theory and data in model making, and it goes on at both an abstract and specific levels, ladies and gentlemen. So econometricians are more deeply engaged in thinking through the philosophical aspects of their modeling strategy compared to the mathematical modeling colleagues on the other side, ladies and gentlemen. So it's very important for us to understand these things, right? So that's why in the 1930s and the 1940s, right, the modeling process, right, involved really making decisions about certain things. So the discussions we are pursuing here indeed go back to the foundations of modeling in econometrics during the early 1930s, during the 1930s and 40s. And that's why you have the infamous measurement without theory debate over the role of theory, both in economic and statistics, right? And that is in the use, making use of econometric models, and of course what happened thereafter when the concepts and the formulas from mathematics were introduced in econometrics, ladies and gentlemen. So in spite of these rhetorics, ladies and gentlemen, it is also not possible simply to confront theory with the data. And it is not really very possible, as you can see, to simply apply theory to data. And for all the prosaic reasons mentioned, ladies and gentlemen, economic theory does not provide all the resources needed to make econometric models that can be used for measurement or testing. All theories are rarely rich enough to do justice to the complexities of the data that has been collected from the field. So that is why those who developed econometrics, ladies and gentlemen, introduced and developed the notion of model in the first place. So they talk about model, right? Now, model is taken as a necessary object in which the matching between theory and data could be accomplished. So that's why you start with the model, and you have a theoretical model, right? So, but despite these debates, there are no general agreed scientific rules for modeling, ladies and gentlemen. That one you need to know. And there continues to be fierce arguments within econometrics community over the principles for modeling and the associated criterion for satisfactory modeling, ladies and gentlemen. So, within this debate, as again I have argued before and right now, please continue reading and reading, right? Because the debate is not quite so simple, because associated within this main question that we are discussing, issues of how statistical data are analyzed and how statistical testing goes ahead. And again, this current debate that we are engaged in can be well understood in terms of idealization and de-idealization, provided we include notions about statistical aspects of models, as well as the economic and the mathematical in the resource base for modeling, ladies and gentlemen. So the debate is not quite easy, and it's a little bit complex, but at the same time we must take that route, ladies and gentlemen. So in closing, ladies and gentlemen, right, one, I must thank you for being so attentive and for really trying to listen in and take in this subject that can be considered to be quite difficult to comprehend and also to take on and try to practice. But we know very well the debate is not a simple debate. The debate of idealization and de-idealization as we apply it in economic theory. At the same time, we know that econometricians really are fond of making many assumptions about distributions. They also try to fix particular statistical difficulties one by one, and they do this in processes that might be thought equivalent to the ways in which economic models are made tractable, and therefore that's why we discuss issues of idealization and de-idealization. So the arguments are complex and technical, ladies and gentlemen, but as with those on causal modeling, well tuned into more general arguments in the philosophies of science and statistics become very critical, and that's why we are studying the philosophy of science in economics, ladies and gentlemen. So I want to thank you and again remind you that our topic that we have started today was and is models and modeling in economics, ladies and gentlemen. And today we have only covered one aspect, and that is I've given you the introduction. I've taken you through the nature of economic models, but more so, we have looked at models as idealizations, and that's what we have discussed today. We've gone through idealizations, we have discussed de-idealization, and also the idealization versus de-idealization debate in econometrics. So next time when I come back, ladies and gentlemen, we shall discuss models as constructions. Thank you very much. Stay home, stay well, and stay safe. I wish you a nice day. Bye, ladies and gentlemen.